Okay, students, good afternoon. Thank you for finding your seats. Excellent. Thank you for finding your seats. Good afternoon. My name is Mr. Brady. It's good to be back for another Friday with you all. So, if you've had a chance to take a look up at the screen and take a look at this meme, how does this meme relate to what we talked about last week? Take a minute to talk to table partners about what we talked about last week, how that relates to what we talked about.
Yeah, same. I was numbered because I was sitting somewhere. Oh yeah. And I was in a rush because everybody was gone.
You think, how does that mean? Okay, class, voices off in 3, 2, 1, 0. Thank you. Okay, now that you've had an opportunity to discuss with your classmates, how does that relate to our discussion last week? What were we discussing last week? Yes, sir.
We were talking about how one person thought that all the continents should be formed in one. So, and then in this photo, there's South America and Africa.
Okay.
And then there's the
What happens when they break up? Yeah.
2 different continents.
Okay, 2 different continents, but what happens next? After they broke it up, what happens? Yeah.
Water forms around it.
Okay. And does anybody remember the theory? So there's this guy about 100 years ago that came up with this idea that these pieces moved apart over time. What did he call his theory? What was the name of it? Yeah. What was the name of the theory? Yeah. Close. It's part of it. He called it continental drift. And what does it mean for things to drift? Yeah.
Not so like connected to them, but they're going somewhere.
Okay, so with this theory, you have this theory that these plates are actually drifting apart. So these different continents are actually drifting apart from each other. How did he support his theory? What did he provide to convince other scientists that his theory was accurate? We talked about 3 specific things he used to support his theory of continental drift. What's one?
Folded mountains.
Okay. What's another one? Let me think. What's another one? We have folded mountains. What was another piece of evidence? Okay. Come back. Yeah.
Like planets fitting together.
Okay. There's one final piece that helped explain that it didn't just happen in a few seconds. There's one final piece that showed that this actually happened over a long period of time. Thank you guys for having your hands up. We're looking for some new voices. What might we find on these continents that can let us look back into the past millions of years? Give us an idea of what might have lived on those continents. Yeah.
Well, of course, trees.
Okay. What do you think?
Dinosaurs.
Real living dinosaurs?
You know, like extinct dinosaurs.
Okay, and when we find dinosaur bones, we call those, what do we call those dinosaur bones?
Fossils.
Fossils. So, the evidence he used to support his theory were those folded mountains and fossil evidence and how those different continents piece together. And last week, I got a good question. I got this question, why aren't all the continents smushed together? What does that mountain look like to you guys? What has happened to that mountain? Yeah, what happened to it? Okay. What do you think?
They technically came together so that
It's like if you took this layered sandwich and took this other layered sandwich and then smushed them together. And our layers go from being clean to these warped layers. We'll talk more about this idea about how these different objects got smushed together. But first, let's look deeper into this theory. So he called this landmass where all those continents were pieced together Pangaea. And how many millions of years ago do we think Pangaea was formed? Yeah.
225 million years ago.
A long, long time ago. And with that theory of continental drift, he had this idea that over time, those continents started to move apart. And what are you noticing about time? Which direction is time going as we move and the continents move? Yeah.
So you started to go down.
Go down to where? To now. So this is what our planet looks like today, and these are the arrangement of our continents. But if we go back 225 million years ago, we can find Pangaea. So using that evidence to support his theory, Wagner said continental drift actually is what caused these continents to move. But my question to you, what size are continents? If you had to give them like a description of a size, how would you describe a continent? Big, like how big? Really big. If you've got these really big continents moving around, what do you think we would observe if these giant continents are moving around the Earth? Take about a minute to talk with your table partners about what we could see as scientists.
These are an hour, 75 seconds.
Okay.
Look at us. I didn't know
Okay. So what would we observe in this? Take about 30 more seconds to come up with some ideas. How would these giant continents, with all this energy, be moving around? What might we observe? Okay. How does an earthquake occur? Okay, what are some of your ideas? We've got these large continents moving through the earth. What are some of the ideas you have? What's one? Okay. What else might we observe if these continents are moving apart? Or moving in general? Yeah.
Well, I was thinking, like, probably, because, because for the past, probably, because it's like 225 years ago, when it was like really young and it was like mostly alive.
Yes.
But then for the past few years, I thought it got really old and started to break apart.
Okay.
Yeah.
Let's take a couple more ideas. Let's take a couple more ideas about what we might observe. Yeah.
Fall over like every 5 seconds because it's moving. You get your ground taken out from underneath.
Okay. Has that ever happened to you?
No.
Anybody else? Have you had the ground just slip out beneath you? Okay, we'll take one more observation about what might happen if these continents are moving. Yeah.
Since electricity and they also
Okay. So with this idea, these are some good ideas. Earthquakes are interesting. If we have these giant continents, those continents, just because of their size, will have a lot of energy. So, what do you know about earthquakes that can help us with this theory? What do you know about earthquakes? What is an earthquake? Yeah.
the ground shakes, breaks.
Okay. What else? What do you know about earthquakes?
Isn't it like I don't know what the like it's like I don't know what the word is, but it's like these plates like they overlap, right?
Okay. How does that relate to earthquakes then?
And like the like ground overlaps, and then that causes the ground to start shaking like that.
Okay. And where do you think earthquakes occur? In a moment, I'm going to hand out maps and some information about where earthquakes occur in the world. Talk with your table partners about where earthquakes occur in the world.
Don't ever sleep in
Okay.
I watch a lot of this and I finally know what to do. I watch a lot of it. Yeah, because I love it.
Okay, class. Thank you. Okay, for this activity, we're going to work in pairs. I'm handing out a map of the locations of the earthquakes around the world. It is your job to find and see if they match up with your map. You're looking for where your earthquakes might occur in the world. This is real data that we're using that's been recorded by NOAA. They're the National Oceanic Atmospheric Association, and they're a coalition of scientists that study Earth activity.
No, nothing's up. I know. You're smart.
Yeah, we all need it.
Stay here. No, it's called math. Add these two together.
But how do plates move to create those?
It's either something wrong with the world or something positive. No! Nobody asked.
Why do you think there's so many earthquakes?
I was never. It was. Ever do that again? How did this? Hurry! She'll take her eyes away. Just add these two yeah. Okay, done. Found it.
Do you like watching it and watching everybody playing it? It's like,
What states are over here? This is for California. This is California. That's 800 that are over here. earthquakes?
It's just weird how you try.
Getting close. Okay, class, put your maps down in 3, 2, 1. Voices off, please. Right. With your earthquake data, what have you noticed? Where are earthquakes occurring in the world? California. Where else? Yeah.
Like around the borders.
Pardon?
Around the
Borders of.
the continent.
Okay.
It really can, I'm not going to say specific place, but like in America, there's a lot of
So we're talking about earthquakes on land. Where else do earthquakes occur? Where else are we seeing earthquakes in the world?
South
So I saw a lot of people had it lined up so they have earthquakes along here. Where else are earthquakes occurring? We see a lot on land. Where else are earthquakes occurring? Yeah.
oceans.
In the oceans. Why are earthquakes happening in the ocean? What are your thoughts? How are earthquakes occurring in the ocean?
Because despite what some of us may think are still tectonic plates in the ocean, they're not just on
Okay. So, earthquakes are a sign of a lot of energy. They're a really strong, powerful process that happens on our planet. What's another really powerful process that happens on our planet? Yeah. Yes. So, the second piece of data I have for you, we have maps of volcanoes. So, using your volcano maps, try to identify where volcanoes occur in the world as well.
No.
So, of course, it's going to be on Mars.
Okay, so I crusty crab, my crusty hamburgers. Yeah, don't try. Don't even try. When you study hard, don't even try asking them. They'll say that's probably not.
Alright,
So what else is occurring? So
there's underwater
why aren't they?
Yeah. Maybe your mom should tell us now.
The Pacific Ocean's pretty
What
What patterns are you seeing? How did they build up?
And then he tries. I don't want to end it.
Clap once if you can hear me. Clap twice if you can hear me. Clap 3 times if you can hear me. Okay. With our earthquake data and our volcano data, what are you noticing? What are you starting to see? Yeah.
When I overlapped them, I saw that the volcanoes and the earthquakes on the coast near the U.S. were really similar. That they were like overlapping like that, so that might have that's a similarity.
Okay. What other observations are we making? What did we see? Yes.
Also, like there's like where more earthquakes happen, and then everyone also goes.
So why are we seeing so many earthquakes in the same locations as volcanoes? Why are there so many along the coast of South America and the coast of North America? Why are they both happening in the same places?
Because when there's an earthquake, it might trigger a volcano eruption.
Okay. But we've got some earthquakes over here and no volcanoes. In fact, this looks like a pretty blank space. Why don't we have any volcanoes or earthquakes over there? Why are they all occurring in the same areas? All right. What do you think?
There's more population in the borders of South America and North America.
Population of people. Okay. Why else might we see earthquakes and volcanoes in the same place? Yeah.
They're basically together whenever there's a borderline which is not a plate. So there's no borderlines in the Pacific Ocean. So there is no volcanoes. There's barely volcanoes or earthquakes happening there.
This idea of plate, what do you mean by plates?
Like, it's basically stuff that the continent lies on.
I thought the continents were moving.
Stuff underneath the continents are moving.
What's the stuff underneath the continents?
Plates.
Plates. We're going to explore this idea about plates. So we're actually going to travel to what's called the Mid-Atlantic Ridge. So this area right here, the Atlantic Ocean, we're going to travel to the Mid-Atlantic Ridge and see one of these areas where we have earthquakes and volcanoes underwater. What question do you have about this idea that there are plates on which the continents sit and move throughout the planet? What questions do you have about that? So what evidence did they point to at the Mid-Atlantic Ridge? What's happening at this Mid-Atlantic Ridge? What did they say was happening right here between these two plates, the South American plate and the African plate? What is happening right there? Oh, you're just stretching? Okay. What's happening right there?
Rubbing together. Earthquake.
And what's coming out? You're kidding me. So what they were pointing to is this idea that's called seafloor spreading. Those two plates are actually moving apart. And they call that concept seafloor spreading. But how would you know the seafloor is spreading? what evidence would a scientist need to show that the seafloor is actually spreading where those two plates are separated? Yeah.
Probably because of the lava, because if you see in the picture, the lava is like spreading in different ways.
Okay, in which directions is the lava going to spread? When it rises out of that trench in the ocean, which directions is it going to spread?
Both, or it's not going to go with this.
How can a scientist measure that lava to identify that it's actually spreading? How might a scientist measure how those two plates spread and how that lava comes out? We'll do a demo to find out. Please make a pile of all your materials and put them closer to the inside of the room. I'm going to come around with these two white sheets. You actually go around and actually make a pile of these, pick those all up, and you can just set them right there on that chair. And then can you two please move your binders out of the way of the center of the table? Okay, please make a pile of those so we can come pick those up. If I don't answer your question today, I will answer it by the end of this lesson, or by the end of this kind of unit. Okay. Now, I need everybody's eyes and ears and your creative thinking, scientific brains. Everybody, please look at the center of your table. What do you notice? Okay. What do you see? Table. What do you see? What's between your two tables?
Track.
Yeah. Track. Imagine the gap between your two tables is the Mid-Atlantic Ridge. So imagine we're underwater and we're looking at the Mid-Atlantic Ridge. This is going to be magma that's coming out of the Earth's surface, or out of the crust of the Earth. So what you need to do is holding on to the top. Notice how there's tape at the very bottom. The tape end should be down, so you should be holding the top where the two pieces separate. Notice how I'm holding the top where the two pieces separate. What you will do is you will put your paper inside of that gap, like so.
I did.
Okay, now, a person on the opposite side of the table from you needs to grab the opposite end. Notice how I have one side, she has the other side. This paper now represents hot magma coming out from the Earth's crust. The person that's not holding the plate, as it rises out, you're going to make marks on the pencil. I'm going to say start, and then you will slowly pull the lava out of the crust. When I say stop, the people pulling the paper will stop. All right, identify who's going to use their pencil to mark where the lava is. More people do that.
I know. Let's do that.
Okay.
Oh, I see.
Students, I'm going to count down from 3 right now. Make a line across your finger to show your starting point. Starting in 3, 2, 1, start. Slowly pulling it out and stop. Make a mark. Starting in 3, 2, 1, slowly pull more magma out. And stop, make a mark, and write number 2 by this mark. Starting in 3, 2, 1, start. And stop. Make it number 3. Some volcanoes erupt faster than others. Starting in 3, 2, 1, go. And stop. And make a mark and write 4. Now, my question, how did the lava move out of the mid-Atlantic ridge? Which directions did the lava move out? Very quickly, which directions did they move? Yes.
The opposite of what it is.
Okay. And with your groups, talk about what is the youngest lava, the lava that came out first, and then identify what the oldest lava. So talk with your groups and identify what the youngest lava was and what the oldest was.
This is the spelled it.
Okay. Which mark did you make first? Okay. Which direction did the lava go? So that's the first mark. Which side came out? Which mark did you make first? Okay. Which mark did you make left? So if you had to identify what the oldest lava is, why would it be one? How did scientists get the lava? What do you think? Which side came out first? Class, I need voices up, please, in 3, 2, 1, 0. We're almost out of time. So, what is the oldest section of lava? What number represents the oldest section of lava? Yes. And what was the youngest?
2.
Actually, what? 4 is not the oldest. 1 is. Okay. And what is the youngest number?
4.
Okay. Which came first? as the lava spread?
Oh,
One came out first, followed by 2, followed by 3, followed by 4. How could scientists use the flow of lava to estimate the age of those plates? How could scientists use this idea of spreading lava to estimate age? Okay. So Pangea was 225 million years ago. In the time since Pangea, what observations would scientists be able to measure at that Atlantic ridge, where lava is spewing out just like this paper? What observations about the age of that volcanic rock? Thank you guys, have a wonderful day. Thank
Have a
you.
good weekend, Tyler. Hey, have a good weekend, party.
You too.
Jackie, leaving me a solid that up. Oh, taxes. Yes.
yeah, the sand in the ocean.
Thank you.
Let's think back about what evidence.
Thanks, Miley.